right, so we're going to pick up right where we left off yesterday. Yesterday, we were talking about how the earth moves. And we started just with rotation. And remember how I said yesterday, you do need to know the actual vocab words. So you can't interchange the words rotation and revolution. Last year, when you were littler kids, it was kind of like ignored if you messed it up. This year, I can't ignore it. If you mess up the words rotation and revolution, you just switch them around, you will get it wrong. And by the way, I'll correct you out loud every time you say it. Like if you're answering a question, you accidentally say rotation, you mean revolution, I will just politely tell you to switch those words around. But anyway, yesterday, as far as we got was this first slide, which says rotation is the earth spinning on its axis. We talked about how it causes day and night in the 15 degrees per hour. But what I want to move on to now is, guys, how do we know the earth is rotating?
Day and night.
We have day and night, but couldn't there be, is there another explanation for day and night?
Yeah, just the sun rotating, we don't.
I think you mean revolves, but
Yeah.
see, that's what I'm gonna do, is change your words. So another explanation was the earth is standing still and the sun's doing the moving, right? That would cause day and night. Because that makes sense, right? Don't you see the sun moving every day? Don't you see it from going at the horizon to high in the sky to low in the sky? So day and night, isn't it? How do we know?
Moon.
What about the moon? Doesn't it rise, get higher in the sky, and then set again?
And then, the wind,
The wind, what about the wind?
the like this, and it changed.
You're right.
Yeah, well, I just can't.
Can't think of it.
Sometimes it throws up steep or crib, sometimes. It throws
Okay,
up
so as what I'm getting at is right now, besides the whole wind stuff that you may or not remember from last chapter, do you have any proof that the earth is the one spinning and the sun is the one standing still? Do you, as a 15/16-year-old kid, have any proof the earth is spinning? You don't, and neither did people in the olden days. It made perfect sense that the sun was the one doing the moving until they discovered a few things. Jake mentioned the whole wind stuff from last chapter. Do you guys remember the whole Santa Claus delivering presents explanation I had? So the fact that this wind curves is because the earth is moving. If the earth was standing still, Santa could easily shoot his present straight down to wherever he was aiming for. So that, if you recall, is called the Coriolis effect. There is some other features. Has anybody ever looked at the stars? Because sometimes, come on, you guys have to notice the stars. Do my kids just notice because their mom's a freaky earth science teacher, or do kids actually look at stars? Sometimes. You at least acknowledge. Does any of you guys like big stargazers?
Oh my gosh, stars.
No. Okay, so I didn't think so. So you may not have noticed this, but I would like you guys, especially with these nice days that are coming up, if you have a bonfire and you're out when it's dark out, can you just go ahead and look at the stars for me? Obviously, this is not a requirement, but I think you should probably start.
Do we have to have bonfire?
No. So if it's a nice day out and you happen to be outside when it's dark out, take a look up and just acknowledge the stars. And then here's the bonus points. If you're out again 3 hours later, so that's why I bring up the bonfire, often out there like a couple hours, look up to see if those constellations and those stars are in the exact same spot.
Well, man, we've never done it.
Because Mrs. Jones, what connection? Never done it? That's what I want you guys to do. If you're outside, when it gets first dark out and the stars are out, take a look, see if you can find the Big Dipper, the Little Dipper. Remember, we learned how to find those guys at the beginning of the year. Does anybody need a refresher course on how you find them? Where is the North Star for us? This is getting completely off topic from where I wanted to go, but I feel like we should talk about it. Why is the North Star important? Let's start there.
Tells you your latitude.
It tells you your latitude. So the altitude of Polaris, the North Star, is equal to your latitude. So what's our latitude-ish?
42.
42, 43. So that's close to 45, right? So straight out, straight up, halfway. So if you point yourself north and you look about halfway up in the sky, you will find Polaris. And Polaris is on the Little Dipper. Polaris is the handle of the Little Dipper. So that's, but it's kind of hard to see. You should be able to find the Big Dipper. The Big Dipper, the two stars of the bucket of the Little Dipper. Oh, let me make these bigger, sorry. This is the Big Dipper. These two stars are called the pointer stars, and notice they point to the Little Dipper. They point right to the North Star. The North Star doesn't move, but every other star in the sky will move every night. In fact, if you recall, the North Star is located directly above the North Pole, so it lives here and it never moves. This is similar to if I stood right here underneath this projector and I stare up at it and I spin. In fact, why don't you guys do this? Stand up. All of you stand up, darn it.
Actually,
And what I'd like you to do is find a spot where you can line yourself up with something obvious on the ceiling. So what I mean is line yourself up with like a cross of the tiles, or if you're right under a smoke detector, line yourself up with that. So what I mean is this dot, oh no, you can't, maybe Ryan would get that dot. Line yourself up with something, get down. Get down. Line yourself up with something obvious, like I lined myself up with that projector. What I want you to do is look up and spin rotate, I should use the proper word. Rotate one time, would ya? While staring at that one spot. What happens to that one spot when you turn?
it seems to be moving.
No, the one spot, like the X. It doesn't move.
I'm busy.
I told you only spin one time. So if you're staring at just that one thing and I made you line yourself up completely with it, that one spot doesn't move. But what did you notice about everything else around that one spot? It moved. It definitely looked like it moved. And if you didn't see this, go ahead and do it one more time. But if anybody pukes because you get dizzy, you're in big trouble. If you're done spinning, go ahead and sit down. That's what happens with the North Star. That's why it's so helpful. The North Star doesn't move. You can always find it in the same spot, but all the other stars in the sky will move. So you may look up and you might find the Big Dipper looking like this at one point, and you go out there again, and it might be in a slightly different spot. You go out there again, and here's where my drawings get difficult. And you might find it in a different spot. And again, it's gonna go where you think that goes all night. What do you think that picture would look like if it kept going? There'd be another one over here and another one over here. I can't draw them all because in the end, it always looks like a swastika and people just judge me when I draw it on the board. No, I'm not going to. It's unfortunate if taken out of context when I have it drawn on the board. So I'm not, for the record, it just looks like it when I draw one and then somebody always says something. So I can't draw the whole thing. But anyway, this is called circumpolar stars. They circle the poles. So these are all proof that the ceiling stood still, but we moved underneath it. It's the same proof that the Earth is the one moving, not the stars themselves. So there is proof. Why are we not moving? There we go. So evidence of rotation. Get those two bullets. We have first the Coriolis effect, Santa Claus delivering presents, remember? And then those circumpolar stars. So while you may not notice the earth is spinning, there are things that if you just happen to look at those exact things, like the stars moving throughout the night, it does prove we're the ones moving, not the stars. I need you to, if you haven't already, you have this exact picture in your packet. Can you label it Foucault pendulum? That is actually the third piece of evidence that the earth is spinning. So again, you have this exact picture. Can you please label it Foucault pendulum? It is the third piece of evidence that proves the earth is spinning. I'm going to now explain what the Foucault pendulum is. First of all, do you guys know what a pendulum is? Okay, you guys know what a grandfather clock is? Those big fancy clocks that have the thing that swings back and forth. That thing that swings back and forth is called a pendulum. So a Foucault pendulum is a thing that swings back and forth. It's a big ball attached to a long string. That string is attached to the ceiling, maybe 3, 4, 5 stories up. So when I say a long string, I mean a really long string. Yeah, Bradley got it. Yeah, is that what you said they got them at the museum? They do have, they have them at almost every science museum you go, including the Buffalo Museum of Science. I am the worst science teacher ever and have not been to the Buffalo Museum of Science since I was like 5. I know, my children have never been there. Maybe I should put it on a bucket because I'm a terrible human. That is fine.
This was a first grade field trip.
Thank you. First grade field trip, then. It is probably meant nothing to you, but basically it's like an elevator shaft, like a place where an elevator goes up and down. And you can look down and you see this ball swinging back and forth. And the Buffalo Museum of Science.
Oh, I've been there.
Yeah, first grade.
No?
Probably last time I was there too.
I remember my fourth.
So maybe I should put it on my bucket list, but it meant nothing to you at the time. I'm gonna pull up a video of one just in case you forgot what they look like. I actually don't like this one. This one is prettier. So this is not super exciting. Again, just like you can go all the way off your thing. No. Just like it didn't mean anything to you then. Now it's still not that exciting. This one's prettier than the one at the Buffalo Museum. So we got the big ball again. We've got these little, it's swinging back and forth. And by the way, you guys know objects in motion stay in motion. Or at least you've heard that.
Is there any wind resistance to it?
No, so it is, if you notice, I don't know if you can quite see, it is, it's like closed off. It's like in a glass elevator shaft, kind of like the one at the Galleria where you go up and it's like a clear tube.
So you're telling me if I were to walk in and stand in front of the ball, I could stop moving?
Yes, you could, but objects in motion stay in motion.
Oh, unless acted upon.
Thank you. What is this cough all of a sudden? Yeah,
COVID-19. I'm gonna fight you.
it's not. I've been bit already. What, Ms. Jones? It does swing all day long. And you notice these little pegs all around. Notice the one that it's close to is standing up, but right off to the right there, they're actually knocked down. Because of the way the Foucault pendulum works, and it is a little above our heads on exactly the physics of it, but it is attached to a very long string on the very tall building. So basically that point stays still and the earth spins underneath it. And it will eventually knock down all of these little pegs. So it appears that the Foucault pendulum is turning how it's swinging, but really it's not the Foucault pendulum turning, it's the ground underneath the pendulum. So they must manually either go in or they have a button to like kind of like bowling pins, you know, they stand them back up. They must somehow stand them back up. They don't like just magically go
What
off.
do you get to see if you're not-
No, so this video never shows you knocking one down. Cuts out right before it would knock down. I don't know why. I'll show you a different video that's just not as pretty. I don't know why they picked one that didn't get knocked down. Oops, too far. This one knocks it down, but again, not quite as a pretty of a video. So you can see this is a different museum apparently. And here you go, you can see how high it's attached. So it's really high, and that's part of the pendulum, is it has to be really, really high. And nope, not there yet. But same concept, big ball, long string, swings back and forth. So close.
Yeah. Bang.
Oh,
It's pissing me off.
I'm sorry.
Look at it. Oh, get pissed off.
Ooh, I don't know. That is a real good one. Oh, I'm gonna use that for the rest of my life. There, all right. So 1 hour later. Oh, all right, I think you guys get the point. I know if you want to watch this, you guys have YouTube on your own that you can do this. Oh, I didn't say you could do it at here. I said you could do it on your own time. This can be your homework. Yeah, totally. Gonna keep that going in the background. So what do you need to know about the Foucault's pendulum? Again, you don't have to understand all of the physics and how it works, like objects in motion, stay in motion, how the earth spins underneath it. What you need to know is the Foucault pendulum is proof or is evidence the earth is rotating. That is all you need to know, along with those 2 other bullets. In fact, test your knowledge and answer the 3 questions there on page 1. See if you can apply your knowledge of the Foucault pendulum with those 3 questions. Again, I don't think these 3 questions were super difficult. Let's start with a Foucault pendulum appears to change its direction of swing due to why? Answer 2, the spin of Earth on its axis. All right, they changed the words around a little bit. The predictable changes in the direction of a swing of a Foucault pendulum provides evidence of Earth rotates on its axis. So that time they used the vocab word rotates. The first time they did not use the word rotate. And then I do think they tried to mess with you again on question 3. Again, they changed the words around a little bit. The apparent shift in the direction of the swing of a motion on a Foucault pendulum provides evidence of Earth's rotation. So notice they threw the sun in there and the other word revolution as answers just to mess with your head. So again, all you need to know about the Foucault pendulum is it provides evidence that the Earth is rotating. One more way they try to trick you. What would happen if they put a Foucault pendulum on the moon? Same thing would happen, but what would it provide evidence of then on the moon? The what? Do that? So let's try this again. They take the Foucault pendulum. They put it on the moon. The same thing would happen. But then it provides evidence of what? The moon rotating. So not revolving, it never has to do with revolving, and it has to do with whatever, if they put it on Mars, it would provide evidence that Mars was rotating. Whatever it's on, it just provides evidence that it's spinning or rotating. So don't let that trick you. The Foucault pendulum provides evidence of rotation. All right, so now we got to talk about the whole revolution side of the Earth moving. So the Earth revolves around the sun. That means the Earth goes around. Yeah, we're on page 2 now. This takes 365.26. Again, you've been lied to your whole lives, but not really, because we always told you about this leap year. We just never told you why. And that's because it takes a little bit longer than 365 days. Every 4 years, we got to add in that extra day. The Earth moves approximately 1 degree per day around the sun. And it's part of the reason we have seasons. It's not the whole reason we have seasons, though. That's all next week, by the way, is we're going to talk about seasons. Part of the reason for the seasons, not the whole reason. Now, again, I'll ask the same question. If you had never been told the Earth goes around the sun, would you know the Earth goes around the sun? Do you have any proof that the Earth is going around the sun? You, as a normal, average teenager, do you have proof the Earth is going around the sun? You don't. Can you explain it? Because you can't. But again, and not just because it's impossible, just because you've never thought of it before. There is proof. And it goes back to the stars again. So nightly, yes, every night the stars go around the North Pole. Yearly, it changes a little bit. So let's say tonight I go outside and I see the constellation projector right above my head. It's directly above my head tonight. How about if I go back in 3 months? What will have changed in 4 months? Where will Earth, have gone? What does the Earth do throughout the year? Throughout the year it revolves, which means it goes around the sun. So there's the sun. I gotta go around the sun. So I'm gonna move around the sun. 3 months later, I'm here. When I look straight up, do I see constellation projector right above my head anymore? No. It's back there behind me a little bit, behind me and to my right. 3 months later. Is constellation above me anymore? Is it behind me and to the right? No. Now it's just to the right of me. 3 months later. Where is constellation projector now? It's in front of me and to the left. Sorry, and I meant left before, not right. But that's okay. The constellations stay still and we move around underneath them throughout the year. That's proof that the Earth is moving. So evidence of the Earth's revolution is the location of the constellations shift depending on the season. This is not all the constellations, it's just the ones farther away from the North Star. For example, the constellation Orion is called Orion the Hunter. Only is in the perfect Orion the Hunter shape during hunting season. So like fall, when all the people were gathering all the food they needed to get through the winter. Other constellations shift again, depending on the seasons, and the Greeks and the Romans and all of the different cultures have all developed their own stories that go with them. And they move, and there's stories that go with them depending on the culture that made the story for them. All right, that is not all we're doing today, but that's as far as we're gonna get with this basic stuff right now. I remember how I said we're gonna jump around a little bit? We're gonna jump around to page 14. So again, nothing we've done so far is news to you. Might have added a few details you weren't aware of, but you knew the earth spun, you knew the earth went around the sun, and you know we have a solar system, right? You know the solar system? Please tell me you knew we had a solar system. Okay, what's that? Well, we're gonna start with, so we'll start with the basics and we'll talk about models of the solar system. Do you guys know what a model is?
Yeah, it's like the one right up there.
Yeah, it's like the one right up there. A model is like a recreation or a representation of something. So there used to be, so this is the correct, this is part of the solar system here. This is just the sun, the earth, and the moon. And you guys know that the earth goes around the sun, we revolve around the sun. Was that always, did everybody always know that?
No.
No. Back in the day, do you guys know what they thought was this? What happened?
Everything rotates here.
Yeah, they thought everybody revolved around the earth. Wait,
Oh, geocentric.
which was called the geocentric model. Now, if I said you're egocentric, what does that mean?
You're self-centered.
You're self-centered, meaning you're the most important thing and everybody else goes around you. So pretty much, yeah, this is the way it is, right? Anyway, geocentric, you've heard the phrase geo before, right? Like what? Geo like earth, like geo like geology, or geo like geography. This is saying that the earth was centered, and this is what they used to believe. And this goes back to when like the church was in charge of everything. And the church believed that God created earth, and therefore earth must be the best, and earth is the most important thing, and everything else went around the earth. Plus, can we bring up that that makes sense, right? Doesn't it kind of make sense that the earth is centered? Is there proof that they could have come up with that the earth is the center? Yeah. What's one piece of evidence that the earth might be the center? Okay, well, yes, that's that. This is where people live, so of course we're the center. But I mean like earth science-y. Does it look like the earth is the center? To us, yes. Because what does the sun do every single day? Goes up, goes down, and assuming it probably goes down and around and keeps going like this. Same with the moon, down and around. Same with the stars. Didn't we just spin and it looked like the stars were going around us? So it made sense. So let's do the rest of the bullets. So it was geocentric, means that the sun, the moon, the stars, the planets move around us. It still explained day and night. When the sun was on top of us, it was day. When the sun went below us, it was night. For the record, the geocentric model is not correct. It's wrong. Shoot, I forgot we're almost out of time. So this is where we'll stop when you have all 4 of these bullets. We'll start with the real model tomorrow. And again, don't forget you have to do your homework, which is that old Regents test, questions 1 through 20, skipping, what is it, 7 questions or 6 questions that we already went over.